In this video, we're going to look at determining positive and negative intervals based on a quadratic function that we have factored. So we want to identify the intervals on which the function y equals x squared minus 2x minus 3 is positive. So the first thing I'm going to do is I'm going to factor this and find the zeros. So I'm going to reset this or rewrite this as 0 equals x squared minus 2x minus 3. I'm going to use the factor sum chart. I'm not going to write that out, but the factor sum chart would give me my factors, and those factors are going to be a positive 1 and negative 3. So if this was factored, I would have x plus 1 and x minus 3. Now the zero product property tells me that I can take each of these pieces and set them equal to 0. I'm actually going to write that the other way around. So I'm going to say x plus 1 is equal to 0, and x minus 3 is equal to 0. So solve these. I get x equals negative 1 and x equals 3. So what that tells me is that these two are the zeros. All right. So I have x equals negative 1 and 3, which tells me there's going to be 3 intervals. All right, I'm going to make a little chart here. I'll do that up here. And what I can have is I can have numbers that are less than negative 1. I can have numbers that are in between my two zeros, negative 1 and 3. And I can have numbers that are greater than 3. All right. So again, those being those zeros. So you have numbers between those two zeros. You'll have numbers to the left, which would be less than negative 1, and numbers to the right, which would be x is greater than 3. When we go through the graph, it might make a little more sense. Now, to determine whether they're positive or negative, it's a pretty straightforward process, although it's a little annoying to do. You're going to take your original function, whatever one that you want. It doesn't really matter which one you pick, but pick any number smaller than negative 1. Okay, so something that fits this criteria. It's less than negative 1. Well, I'm going to pick negative 2. So I'm going to take negative 2 and plug it into my original problem. Okay, so this is coming from, this whole piece here is coming from the equation that they gave me, or the function that they gave me. So when I solve this, I get 4 plus 4 minus 3. 8 minus 3 would be 5, and that is a positive number. So since that's positive, that means that interval, x is less than negative 1, is going to be a positive interval. Now I'm going to do the same thing for this middle piece and the right piece. So something between negative 1 and 3, easiest number clearly to work with in this case would be 0. So I'm going to plug in a 0 into my original equation. So I get 0 minus 0 minus 3. That's going to be 0 minus 3, which is negative 3, and that is negative. And now I can pick any number greater than 3. I'm just going to go with 4. So 16 minus 8 minus 3. So that would be 8 minus 3, which is 5, and that is positive. So my 3 sections, or my 3 intervals, what's going on here is that the interval x is less than negative 1 is positive. The interval from negative 1 to 3 is negative. And the interval x is greater than 3 is positive. Now the question was identify the intervals on which the function is positive. So those intervals will be x is less than 1. Well, actually, let's not box that whole thing in. So my intervals would be x is less than 1, or sorry, less than negative 1, and x is greater than 3. Now, how do I know that this is true? How can I make this easier? Well, if I look at a graph, based on my work, I know that I have the zeros negative 1 and 3. Take my word for it. The vertex in this case is going to be 1, negative 4. So my parabola is going to look something like this. All right, it's not drawn perfectly, but that'll do. This piece down here from negative 1 to 3 is below the x axis. So that means that it is negative, which makes sense. All right, we knew that was negative here. And the two intervals here are positive. So my graph matches up with my work. Now, does all this work need to be shown? No, to be honest, this is kind of a silly method to figure out whether something is positive or negative in terms of intervals. Clearly, if we graph it, which is going to be a lot easier than plugging in a bunch of numbers, we can clearly see what intervals are positive, what intervals are negative. This does become a little bit more useful when you're dealing with cubics or something to like the fourth power when you're graphing these, because then you're going to have more sections that you have to look at. But again, going by a graph is almost always going to be easier for these types of problems. Um, One of the nice things you can look at as well is if you know that the graph opens upward, like in this case, then those two outside ones are going to be positive. All right, if my graph had opened, let's say, downward, then positive would wind up being between my zeros. All right, so that would be in this case here. All right, that's going to be the case anytime it opens downwards, is between your zeros would be positive. If it opens upwards, like in the problem that we worked out, if it's opening up, then outside of your zeros will be positive. So if you can kind of keep that in mind, that might help you a bit. Again, showing all this work, not always necessary. Textbooks really like to show this method for whatever reason. If you learn how to interpret graphs, it becomes pretty easy. Okay, all you need to do is look at the graph, and then once you get better at these, just knowing whether it opens up or down will tell you whether the intervals are on the outside, the positive interval, sorry, is outside of your zeros or between your zeros, and you'll be able to figure out the negative intervals just as easily.